In a series circuit containing a 30-volt source, a 5 ohms load 1, a 7.5 ohms load 2, and a 10 ohms load 3, determining the voltage across load 2 involves a few straightforward calculations. Firstly, you need to determine the total resistance of the series circuit. This is found by summing the individual resistances of each load. In this case, the total resistance equals the resistance of load 1 plus the resistance of load 2 plus the resistance of load 3. Therefore, the total resistance is 5 ohms plus 7.5 ohms plus 10 ohms, which equals 22.5 ohms. Secondly, calculate the current flowing through the series circuit. This can be determined using Ohm's law, which states that current equals voltage divided by resistance. The voltage is 30 volts and the total resistance is 22.5 ohms. So, the current equals 30 volts divided by 22.5 ohms, resulting in a current of approximately 1.33 amps. Thirdly, calculate the voltage drop across load 2. This is achieved by multiplying the current flowing through the circuit by the resistance of load 2. Since the current is 1.33 amps and the resistance of load 2 is 7.5 ohms, the voltage across load 2 equals 1.33 amps multiplied by 7.5 ohms. This results in a voltage of approximately 9.98 volts. Rounding this to the nearest whole number gives you 10 volts. Therefore, if a voltmeter is placed across load 2, it would display a reading of approximately 10 volts. In summary, calculating voltage in a series circuit involves 3 primary steps. Firstly, find the total resistance by adding the resistance values of each load. Secondly, determine the current using Ohm's law by dividing the voltage source by the total resistance. And thirdly, calculate the voltage drop across the specific load by multiplying the total current by the resistance of that load. These steps ensure an accurate determination of voltage distribution in a series circuit.